The air in the dimly lit hangar hung heavy with the grim scent of conflict, yet an unexpected aroma permeated the space. Dr. Karl-Heinz Honkel, a senior Luftwaffe engineering specialist, stood before the mangled yet oddly intact wreckage of a British de Havilland Mosquito Bomber. It wasn't the acrid tang of burnt aviation fuel or scorched aluminum that dominated. Instead, an almost incongruous perfume filled his nostrils. The faint, clean smell of wood, like a master carpenter's workshop, not a battlefield casualty. To Henkel, a man steeped in the meticulous metallurgy and advanced aerodynamics of German aviation, the very notion of a wooden combat aircraft was an anachronism, an insult to modern engineering. His initial reaction had been one of professional contempt, bordering on amusement. How could a nation priding itself on its technological prowess resort to crafting warplanes from glorified furniture? Yet, this wooden wonder had become a spectral menace. It had consistently outmaneuvered the Reich's finest interceptors, delivering precision strikes deep within German territory, often with impunity. Honkel ran a gloved hand over a splintered spar, the multi-layered plywood revealing itself beneath the shattered paint. The sheer absurdity of it struck him with profound bewilderment. How could a machine forged from humble timber, a material considered fundamentally unsuitable for high-performance combat aircraft by the stringent standards of the Luftwaffe, defy every engineering doctrine they held sacred? This wreckage represented not just a downed enemy aircraft, but a stark, almost existential challenge to Germany's technological supremacy, laying bare a fatal misunderstanding that would ultimately haunt their war effort. To understand this profound irony, where the technological titan of the Third Reich found itself baffled by what it perceived as a relic, we must rewind to Britain in 1938. The shadow of war loomed large, yet the British Air Ministry, caught in the grip of conventional doctrine, was in a precarious strategic position. Their industrial capacity, while formidable, faced critical limitations, particularly in strategic materials like high-grade aluminum alloys, essential for modern aircraft construction. It was against this backdrop of impending crisis and resource scarcity that a radical proposal emerged from the drawing boards of the de Havilland Aircraft Company. Here, a visionary team, led by Sir Geoffrey de Havilland, and particularly his chief designer R.E. Bishop, dared to challenge the prevailing wisdom of aerial warfare. Their concept, designated originally as the de Havilland DH-98, was audacious. A fast, unarmed bomber and reconnaissance aircraft constructed almost entirely from wood. When presented to the Air Ministry, the initial response was one of outright skepticism, bordering on derision. Air Staff Requirement B-1240, a crucial document outlining specifications for future bomber aircraft, famously dismissed the concept. The Air Ministry, ingrained in the belief that bombers required heavy defensive armament and armor plating to survive enemy fighter interdiction, saw the DH-98 as an anachronism. "We do not consider that an unarmed bomber would be acceptable," was the official stance, a direct reflection of the doctrinal rigidity that prioritized defensive firepower over sheer speed. Yet, de Havilland's team held firm in their conviction. They argued that speed itself was the ultimate defense, rendering heavy armament and armor superfluous. This was a radical departure from the norm, a paradigm shift that many in the Air Ministry found difficult to grasp. Their design philosophy was simple yet profound: go fast and go light. The choice of wood, initially seen as a weakness, was in fact a stroke of genius born of necessity and foresight. Britain's aluminum supply was finite, facing immense pressure from fighter production. Wood, however, was plentiful, and, crucially, the nation possessed a vast pool of skilled woodworkers, cabinet makers, furniture manufacturers, and even piano builders, whose expertise could be rapidly repurposed for aircraft fabrication. This allowed for decentralized production, reducing vulnerability to concentrated bombing raids and bypassing the specialized heavy industrial infrastructure required for metal aircraft. The material itself, primarily balsa sandwiched between layers of birch plywood, was to be bonded with a revolutionary new adhesive, a urea formaldehyde glue known as aerolite, creating a monocoque structure of immense strength-to-weight ratio. This improvisational ingenuity, this willingness to discard dogma in the face of constraint and embrace unconventional solutions, stands in stark contrast to the industrial might and rigid engineering philosophy of Nazi Germany. While Germany poured its resources into complex, metal-intensive designs like the Heinkel HE-177, Britain was quietly, desperately, nurturing a design that would soon become one of the most versatile and lethal instruments of the war, the Mosquito. Its birth was not one of overwhelming industrial capacity, but rather of a singular vision, backed by a desperate necessity, and a profound understanding that innovation often flourishes where conventional paths are blocked. The initial German reaction to the de Havilland Mosquito's existence was one of dismissive arrogance. Here was the Third Reich, a titan of industrial metallurgy and advanced aeronautical engineering, confronting an enemy supposedly reduced to constructing high-performance aircraft from plywood and glue. But this initial scorn would quickly transmute into a gnawing frustration, then outright panic, as the wooden wonder carved a relentless path through the heart of the Reich's air defense. The Mosquito's combat debut was deceptively understated, primarily in high-altitude photo reconnaissance missions over occupied Europe from September 1941. It was here that its unparalleled speed became devastatingly clear. Flying at altitudes often exceeding 30,000 feet and speeds well over 400 miles per hour, the Mosquito frequently outran any intercepting Luftwaffe fighter, including the formidable Focke-Wulf FW-190 and the Messerschmitt Bf-109. German pilots reported encounters where the enemy aircraft simply pulled away, leaving them in its wake, unable to close the distance for an effective firing solution. The true strategic nightmare for the Luftwaffe began when the Mosquito transitioned to bomber and fighter armor roles. Its speed was not merely a defensive asset, it transformed offensive tactics. The aircraft could execute pinpoint daylight bombing raids against high-value targets deep within German territory, often flying below radar detection thresholds or simply too fast for ground defenses to react effectively. The German air defense network, heavily reliant on early radar systems and interceptor squadrons, found itself repeatedly outmaneuvered by an aircraft that seemingly vanished after delivering its payload. Perhaps the most potent demonstration of the Mosquito's disruptive power came with its audacious raids on Berlin. On January 30th, 1943, on the 10th anniversary of Adolf Hitler's ascent to power, Mosquitoes of No. 105 Squadron RAF conducted a daylight raid on the main Berlin radio station, disrupting a live speech by Hermann Göring. This was not a raid designed for mass destruction, but a calculated psychological blow. It sent an unequivocal message to the German leadership and populace. No target, not even the capital, was beyond the reach of the Royal Air Force, and the Luftwaffe could not guarantee its defense. This psychological warfare was deeply impactful, eroding morale and confidence in the regime's protective capabilities.
Für das High Command, der Mosquito bekam mehr als nur ein Flugzeug. Es war ein persistentes, unlösbares strategisches Problem. Its unique composite wood construction offerte einen reduzierten Radarsignal gegenüber konventionellem Metallerdkraft, machen Early Warning und Tracking inhärent diffizil. Its agility, born from its lightweight yet robust structure, erlaubte es zu evadieren Flak- und Fighter-Attacken mit bemerkenswertem Erfolg. Die Lacke-defensive Armament, initial ein Punkt von Contention während es Design, war probenirrelevant. Its Eat war its Armor. Der Mosquito forste die Luftwaffe zu divertieren presswerte Ressourcen, Squadrons von Interceptors, Radarentwicklung, Anti-Aircraft-Batterien zu countern einer Threat, die sie selten Loch nicht der Thron konnte. Its Operations exposed kritische Vulnerabilitäten in dem Reichs Air Defense Doktrin und Technologie, Vulnerabilitäten, die nur diefen werden, als der War progressierte. Das Sustained, das geologische und strategische Impact des de Havilland Mosquito hatte bei Late 1942 und Early 1943 eskaliert von einem Meere Nuselns zu eine profunde operationale Embarrassment für das Oberkommando der Luftwaffe. Der Reichs-Air-Defense-Strategie, prädikiert auf einer Superiorität in metallischer Erdkraftkonstruktion und Heavy Armaments, fand sich örtlich ausmanövriert von einem Adversar, das sehnlich every establishte aeronautische Prinzipien. Reports von Fighter Squadrons, consistently detailed engagements, wo der Mosquito simply accelerated away, oft mit seinen Engines an maximaler Continuous Power, lassen die Most Advanced Luftwaffe Interceptors trailing helplessly in its wake. Diese operationale Impotenz fühlte eine diepe, siedende Frustration in dem German High Command, kulminierend in einem urgenten, uneindeutigen Direktiv. Ein Mosquito muss gefangen werden, intakt wie möglich und subjektiert zu einer forensischen Ingenieursanalyse. Die Opportunität ergab sich in Early 1943 folglich einer Low-Level-Reconnaissance-Mission über Norddeutschland. Ein Mosquito, leidlich geschädigt von Groundfire, executed eine Forstlandung in einem occupied Territory, bleiben sufficiently intakt für detaillierte Examinierung. Dr. Karl-Heinz Hanke, ein distinguierter Materialwissenschaftler und aeronautischer Ingenieur, angeschlossen an das Technische Amt des Reichsluftfahrtministeriums, wurde immediat mit Leiten der Investigation beauftragt. Sein Team, comprising Spezialisten in Metallurgie, Aerodynamik und struktureller Ingenieuring, konvergierte auf den erhobenen Airframe sequestrated in einem heblich gewahrten Hangar. Als Hankels Team zuerst den Wracke näherte, ein pekuliärer Geruch prämierte die Luft. Es roch wie Vöbel, nicht wahr? Dieses immediate sensorische Kontrast, so örtlich unerwartet im Kontext eines Hochleistungskampfflugzeugs, unterstrich das Enigma, den sie fällten. Initiale externe Ausbiesungen hatten das Offenbare ergeben. Der Airframe war in der Tat primär aus Wood konstruiert. Disglaube war das pervasive Sentiment, eine Ablehnung von dem als technologische Regression angesehen. Yet der Mosquitos Proven Combat Effectiveness kontradierte dieses initiale Vorurteil. Hankels Team meticulous desezierte den Airframe. Unter powervoller Laborlampen entdeckten sie eine sophisticated Plywood-Laminatkonstruktion. Lagern von Birk und Balsawood wurden in einem komplexen Sandwich-Struktur zusammengeklebt, formen einen Monocoque-Fuselage und Wing-Sections, die gleichzeitig unglaublich leicht und erstaunlich rigide waren. Dieses Composite Structure nutzte nicht nur außergewöhnliche Strenge zu Gewichtsverhältnisse, sondern besaß auch inhärente Vibrationsdämpfungseigenschaften. Aber die true Revelation, der technologische Linchpin, das defiete konventionelle Unterstände, lag in dem Adhesiv. Chemische Analyse bestätigte den Gebrauch von Aerolite, einem Ureaformaldehydresin, der mit einem Hartener eine robuste thermosättige Bindung erzeugte. Noch kritischer war die strukturelle Integrität der hauptlasttragenden Komponenten, besonders der Wingspars und Fuselagehälften, auf einer hocherwarteten Phenolformaldehyd-Balltaufe. Diese synthetische Resin, speziell Tegofilm, wurde als dünner Film zwischen den Wood-Venieren angebracht und unter Hitze und Druck ausgehärtet. Die entstandenen Bindungen waren so resilient, so örtlich mit den Woodfiesern verschmolzen, dass sie Reporters heißen stärker als Stahl waren. In ihrer Zug- und Scherkraft.
The initial scientific dismissiveness within Henkel's team quickly transitioned into a grudging, almost resentful admiration. The elegant simplicity of the concept, combined with the profound sophistication of its execution, represented a paradigm shift. This was not merely a wooden aircraft, it was a testament to innovative material science and manufacturing processes, exploiting readily available non-strategic resources to create a weapon system that consistently outperformed Germany's most advanced metallic aircraft. The Mosquito was not primitive. It was, in a critical and uncomfortable sense, revolutionary. Following the detailed analysis of the captured Mosquito, the Luftwaffe High Command faced an undeniable truth. This wooden marvel was not a fluke, but a strategic weapon of immense capability. The operational successes of the Mosquito, particularly its audacious daylight raids over Berlin, began to inflict not just material damage, but also a profound psychological blow. It became imperative to counter this threat, and for a nation that prided itself on unparalleled engineering, the most direct solution seemed to be replication. Thus, in late 1943, Project Muka was formally initiated. The mandate was clear: reverse engineer the de Havilland Mosquito and produce a German equivalent that could match or even surpass its performance. There was an initial, almost arrogant confidence within the Reichsluftfahrtministerium, RLM, and its cadre of brilliant engineers. The prevailing sentiment, often echoed in technical briefings, was that if the British, with their perceived limitations in strategic materials, could craft such an aircraft from wood, then superior German ingenuity could surely perfect it. This was not merely professional ambition, it was a matter of national prestige and a tactical necessity. Dr. Karl-Heinz Henkel, despite his prior reservations about the feasibility of such a project, was tasked with leading the technical efforts. His team, composed of some of Germany's finest aeronautical designers and material scientists, began the arduous process of dissecting the salvaged Mosquito down to its individual fibers. Initial reports confirmed the multi-laminar birch-balsa-birch plywood construction, a design that offered remarkable strength to weight ratios. However, the first critical challenge emerged immediately. Germany lacked readily available supplies of high-quality birch plywood and balsa wood on the scale required for mass production. Their industrial complex, optimized for metallurgy and light alloys, possessed neither the raw materials nor the specialized manufacturing infrastructure for such a wooden airframe. Yet, the true enigma and ultimately the insurmountable obstacle lay in the bonding agent. The British adhesive, a phenol formaldehyde resin, demonstrated properties that baffled German chemists. It created structural bonds stronger than the wood itself, impervious to environmental stresses and the violent vibrations of high-speed flight. German adhesives, while advanced in their own right, simply could not replicate this critical performance. Attempts to synthesize a similar resin proved frustratingly slow and yielded inconsistent results, often failing under simulated operational loads. Furthermore, the manufacturing philosophy behind the Mosquito was alien to German production lines. Where German factories relied on precise metal stamping, riveting, and welding, the British employed furniture makers, cabinet makers, and piano manufacturers, utilizing specialized wooden jigs and handcrafting techniques. The integration of non-metallic tools and a workforce trained in woodworking rather than metallurgy represented a fundamental departure that Germany's rigid, centralized industrial system struggled to comprehend, let alone adopt.
Project Muka quickly devolved into a logistical and engineering nightmare. The belief in superior German engineering began to clash violently with the practical realities of material scarcity, unreplicable chemical formulas, and an utterly foreign manufacturing paradigm. What started as an ambitious endeavor to copy a perceived weakness became a profound illustration of Germany's own strategic inflexibility, revealing that their engineering prowess, while formidable, was often confined by its own dogmatic adherence to established methods and materials. Yet, the strategic inflexibility Germany exhibited was not merely an intellectual failing. It manifested profoundly in the unforgiving realm of material science and industrial logistics. The British Mosquito, forged from humble wood, demanded resources and manufacturing paradigms utterly alien to the German war machine. Germany, a nation whose industrial might was meticulously calibrated for steel, aluminum, and advanced alloys, found itself in a critical material trap. Unlike Britain, which possessed robust supply chains for high-quality birch plywood, often sourced from the vast forests of Canada and Scandinavia, the Reich's wartime economy had no comparable access or infrastructure. Aircraft-grade birch plywood was a specialized commodity, requiring specific timber types, meticulous slicing techniques, and precise lamination for optimal strength-to-weight ratios, a material considered peripheral to German strategic planning.
Their factories, geared for the rapid stamping and riveting of metal airframes, lacked both the raw materials and the fundamental expertise in large-scale, precision woodworking required for a sophisticated composite structure. Furthermore, the seemingly innocuous adhesives proved to be an insurmountable chemical barrier. The British had pioneered synthetic phenol formaldehyde resins, such as tegofilm and aerolite, which, when heat-cured under pressure, formed bonds stronger than the wood itself and impervious to environmental degradation, a true marvel of applied chemistry. The German chemical industry, while formidable, had not prioritized the development of such high-performance aerospace wood adhesives. Their attempts to reverse engineer the captured mosquitoes' bonding agents met with repeated failures, yielding glues that delaminated under stress or deteriorated rapidly in adverse conditions, rendering any replica structurally unsound. Dr. Karl Henkel's team encountered a profound knowledge gap, discovering that identifying the components was one challenge, replicating the precise manufacturing process and achieving the requisite molecular integrity was another entirely. The very essence of German industrial organization, honed for the mass production of metal components, became a significant impediment. Their workforce comprised skilled metalworkers, welders, and machinists, not the specialized cabinet makers and master carpenters whose artisanal craftsmanship was integral to the mosquito's construction. Retooling entire production lines, retraining a labor force for intricate wood joinery, and developing the necessary jigs and presses for large-scale timber construction, all amidst the relentless demands of total war, was a logistical nightmare that the German High Command simply could not countenance. Their industrial complex, a testament to rigid efficiency within its established parameters, proved tragically inflexible when confronted with an entirely new material and manufacturing philosophy. The failure of Project Muka, and indeed Germany's broader inability to replicate the mosquito, was not merely a logistical or material shortcoming. It represented a profound philosophical chasm, a collision between engineering dogma and adaptive ingenuity. German engineering, while undeniably brilliant and meticulous, often manifested in a tendency towards over-engineering. Their designs, from the formidable Tiger tank to the sophisticated Me-262 jet fighter, were marvels of precision and robust construction, but frequently complex, resource-intensive, and optimized for an ideal operational environment rather than the brutal exigencies of total war.
For the Luftwaffe, combat aircraft were synonymous with metal, duralumin alloys, steel, and increasingly specialized composites. This was not just a manufacturing preference. It was an ingrained doctrine, a symbol of technological superiority that defined their aerial might. The very notion of a high-performance combat aircraft crafted primarily from wood, a material often relegated to trainers or gliders, was an anathema. It was perceived as a step backward, an admission of technological inferiority rather than a pragmatic solution born of strategic necessity. This rigid adherence to established principles, while fostering excellence within its own framework, fundamentally stifled the radical, unconventional thinking required to embrace a wooden wonder. Furthermore, the hierarchical and often dogmatic structure of the Third Reich's industrial and military complexes played a critical role. Unconventional proposals, particularly those challenging deeply ingrained engineering paradigms, faced an immense uphill battle for approval and resources. The flexibility and entrepreneurial spirit that allowed de Havilland to pursue a design initially rejected by the British Air Ministry simply did not exist within the German system to the same degree. Ideas had to conform, had to fit within an established metal-centric vision of aerial warfare. German engineers, brilliant in their dissection of the mosquito's physical attributes, meticulously analyzed its laminated structure, the composition of its urea formaldehyde adhesive, and its aerodynamic profiles. They understood the how, the individual components and their assembly, the mechanical intricacies that contributed to its speed. What critically eluded them was the why, the strategic imperative, the resource scarcity in Britain that drove such an unconventional material choice, and the underlying design philosophy that prioritized speed, simplicity, and adaptability over brute force or exotic alloys. They attempted to replicate a product without fully grasping the process, the mindset, or the unique circumstances that had forged it. This intellectual blind spot,
This dogmatic adherence to perceived superiority ultimately became a critical strategic vulnerability, preventing them from truly understanding the adaptable strength of their adversary. As Mucha faltered in the labyrinthine corridors of German industry, the de Havilland Mosquito continued its relentless campaign, a spectral adversary that defied the very logic of aerial warfare. Its ongoing success in the operational theater served as a brutal, undeniable indictment of Germany's rigid design philosophy and its inability to adapt under pressure. While German engineers struggled to master the intricacies of phenol formaldehyde resins and multiply wooden structures, the Mosquito was already executing critical missions, intensifying the Luftwaffe's growing frustration and becoming a potent symbol of German strategic vulnerability. The Mosquito's speed and operational ceiling made it virtually untouchable by contemporary German interceptors for much of the war. Its early role as a high-speed photo reconnaissance aircraft provided invaluable intelligence, penetrating deep into the Reich at altitudes and velocities that rendered conventional defenses largely ineffective. German flak crews, accustomed to the slow, predictable trajectories of heavy bombers, found themselves constantly outmaneuvered by the Mosquito's nimble agility and sheer pace. This dominance was starkly demonstrated in missions such as the daring daylight raids on Gestapo headquarters in Copenhagen and Oslo, or the precision attacks on V-weapon research facilities, where the Mosquito's pinpoint accuracy and rapid ingress-egress negated the numerical superiority of German defenses.
Perhaps the most galling aspect for the German High Command was the Mosquito's pivotal role in the Pathfinder Force, illuminating targets for the main RAF bomber streams. Its precision navigation and bomb aim were critical to the effectiveness of area bombing campaigns, turning German cities into infernos. The Mosquito also conducted the famed nuisance raids over Berlin, flying at high altitude and speed to drop relatively light bomb loads, not for destructive power, but for psychological effect. These raids, often timed to coincide with major German public events or speeches by senior Nazi officials, underscored the Luftwaffe's inability to secure its own capital. General Adolf Galland, inspector of fighters, famously lamented the Mosquito's impact, stating, "The British, who can afford to build planes of wood when we cannot, are capable of building planes that we cannot shoot down." This stark admission encapsulated the strategic embarrassment. Germany, the technological titan, was being plagued by an adversary constructed from plywood and glue, a material they deemed primitive. The Mosquito was not merely a weapon, it was a constant aerodynamic reminder of a critical conceptual failure. The collapse of Project Mucha was not merely a technical setback, it was the downfall of an entire industrial ideology. The Germans approached the challenge with their hallmark obsession for material superiority, standardized production, and rigid engineering principles. They sought a precise formula, a replicable blueprint, but the Mosquito offered no such simple solution. The real genius of the de Havilland Mosquito lay not solely in its laminated plywood or revolutionary phenol formaldehyde adhesives, formidable technological feats though they were. Its foundation was an organizational philosophy born of wartime necessity, nurtured by a culture of creative autonomy, and unburdened by the rigid protocols that often stifled innovation within the Third Reich's monolithic industrial machine. While German engineers were accustomed to a top-down design process, de Havilland fostered an environment where disparate skills, aeronautical design, precision carpentry, advanced adhesive chemistry, converged with unprecedented fluidity. It was a space where the seemingly illogical concept of an unarmed wooden warplane, initially dismissed by the British Air Ministry itself, was not just tolerated but championed. Germany, ironically, became a victim of its own pre-war industrial triumphs. Mastery in metallurgy, jet propulsion, and rocketry had bred an unshakable belief that steel and aluminum equaled superiority, centralized production equaled invincibility. This orthodoxy became a strategic blindfold. The idea that a frontline combat aircraft could be built by cabinet makers and piano builders in dispersed, non-strategic workshops using non-strategic materials was simply inconceivable within their technological paradigm.
The Mosquito was not just a marvel of British ingenuity, it was a scathing indictment of a system that prioritized rigid logic and established methods over audacious, unconventional thought. It proved that sometimes the greatest strength lies not in superior resources, but in the freedom to innovate without fear of convention. The Mosquito story delivers a timeless lesson on the perils of inflexible thinking and the transformative power of embracing unconventional solutions. The British, facing acute material shortages, leveraged ingenuity and decentralized expertise, turning what appeared to be a weakness, reliance on wood and small workshops, into an unparalleled strategic advantage. This approach, bypassing bureaucratic inertia and fostering cross-disciplinary collaboration, was a precursor to what modern industries now call agile development. Moreover, the de Havilland Mosquito was a remarkable progenitor of modern aerospace design, foreshadowing the critical importance of composite materials. Its plywood monocoque structure, using phenol formaldehyde adhesives to create a framework stronger than typical light alloys, was an early, brilliant application of principles that now underpin advanced aircraft, automotive, and marine technologies.
Ultimately, the Mosquito stands as a powerful historical case study for innovation and adaptability. It underscores that even the most technologically advanced nations can be outmaneuvered by strategic foresight, resourcefulness, and a willingness to challenge established paradigms. The failure of Mosquito was not just a logistical or technical defeat for the Luftwaffe, it was a profound philosophical loss, a stark reminder that in warfare and in all complex problem-solving, intellectual agility often triumphs over sheer industrial might. The legacy of the Mosquito is a testament to the enduring truth that the human element, imagination, collaboration, and a refusal to be bound by conventional wisdom remains the ultimate determinant of success.